Thank you for joining me in this series of Ask the Business Data Analyst, where we will explore different questions related to work done by business data analysts. This video is brought to you by Techcanvass, which is an IIBA and PMI Authorized training partner. Techcanvass offers project management, business analysis, analytics, and domain certification training. I am Priya Telam, a senior data analyst with a diversified professional experience of 10 years in various MNCs. I am passionate about using data to solve problems. I am a Tableau desktop specialist and IIBA certified business data analyst. So the question for today is, what is data mining? Now, many of you must have heard this term. But given the broad spectrum of words used in data science and analytics, it is sometimes confusing as to what exactly do we mean by data mining. So in this video, we will look at what is data mining, why it is important, the data mining process, some of the techniques, and finish off with some exciting applications of data mining in the real world. Do you think an ice cream vendor can use the daily sales, online searches for their store, day, date, time, and online comments on their website to determine which ice cream flavor will be most popular in the coming weeks? Well, data mining can provide an answer to this question. Through data mining, the ice cream vendor can analyze past sales, check popular online customer searches, gauge their interests through social media posts, and predict based on the success during this period in the past years. So asking the right questions and collecting the correct data to answer those questions is critical to successful data mining. Organizations use data mining for various applications like risk management, anticipating demand for resources, project customer sales, detecting fraud, increasing response rates to their marketing efforts, and much more. So, can you make a rough guess on what you think data mining actually is? Well, data mining is the process of analyzing enormous volumes of data to find patterns, discover trends, and gain insight into how that data can be used. Data mining tools include powerful statistical, mathematical, and analytics capabilities. Data mining is an interconnected discipline blending the fields of statistics, that is, the numeric study of data relationships, machine learning, that is, algorithms that can learn from data to make predictions, and artificial intelligence, which is human-like intelligence displayed by softwares and machines. So, why is data mining important? Well, data mining is most effective when deployed correctly to improve business, answer questions, or provide solutions to problems. Data mining assists with making accurate predictions, recognizing patterns and outliers in large volumes of data from multiple structured and unstructured sources, which otherwise would have been almost impossible. Well, decades ago, it would take weeks or months to analyze huge data sets to, say, detect fraud. By then, it may be too late to flag records as fraud, right? But now, with advancements in technology, this can be done in hours or minutes, that is near real time. Data mining also helps organizations identify gaps and errors in processes, like bottlenecks in supply chains or improper data entry. We'll now look at the data mining process. This value extraction from data is done systematically using a framework called as CRISP-DM, that is Cross-Industry Standard Process for Data Mining. This is a widely accepted framework. This provides a structure to our thinking about handling data analytics problems. The outer circle here indicates that the process does not end with the deployment here, but it can lead to new projects, maintenance, upgrades, learnings for the next projects, and so on. So let us explore this framework in detail. Now, the first step is business understanding. Ultimately, every organization has questions to answer and projections to make, right? Hence, data mining often begins with a question. The first step in any data mining project is to understand the business objectives or the problem that we are trying to solve. So we begin by asking the question, what problem are we trying to solve using data mining? This lays the foundation of the data mining strategy for solving the problem. Now, once the requirement is clear, appropriate data relevant to the business question needs to be collected. It usually comes from various sources such as sales records, customer surveys, geolocation data, including structured and unstructured data. So this stage may also include exploratory analysis to uncover some preliminary data patterns. At the end of this stage, the data mining team has selected the subset of data for analysis and modeling. Data preparation is the most time-consuming but critical step before jumping into data analysis. Some of the most common tasks performed are extracting and merging data from various sources, checking or improving the data quality by correcting incorrect values, handling missing values, removing outliers, or transforming data into a suitable form for advanced analysis, and so on. So in the final step, the consolidated data is ready for analysis at one single point. In the modeling phase, you'll select the appropriate modeling techniques for the given data. These techniques can include clustering, predictive models, classification, estimation, or a combination of these techniques. We will cover some of these techniques in the next section. Now, after creating the models, you will test them and measure their success at answering the question identified in the first phase. This phase lets you ensure that your progress is on the right track towards the business question. Well, if not, you may have to move back to some previous phase and rework before proceeding to the deployment, which is the next phase. In the final deployment to the real world, insights and actionable information derived from the data are deployed within a target environment, like applying the model to new data or creating new strategies or integrating models into applications and so on. So this was a brief understanding of the CRISP-DM process or the framework for data mining. Now we'll look at some of the most commonly used techniques in data mining. The data mining techniques can be divided into two main purposes. Basically, they can either describe the target data set or predict outcomes through machine learning algorithms. So let us discuss a few techniques. The first one is association. One popular retail store found a strange pattern. People who brought diapers also brought beer, so they were commonly purchased together. As a result, the store positioned beer and diapers nearby, thus increasing beer sales. So association rules seek to uncover the relationships between data points. And many times they link two seemingly unrelated events or activities like diapers and beers. Next is clustering. Clustering is extensively used when segmenting customers based on their past purchases, behaviors, or their attributes. This technique aims to group data by similarities by separating the dataset into different subgroups. Under predictive, the first one is classification. So, say a bank loan officer needs to analyze data to learn which loan applicants are safe and who are risky for the bank. So, this classification task, where a model predicts new data into class labels like safe or risky. This classification is a classic data mining technique in which the data points are assigned to one of the labels defined, and these labels are aligned to the business problem. In case of regression, say when you want to predict the price of a house based on location, number of rooms, square footage, and other factors, regression analysis is the most useful. It is a mathematical data mining technique used to predict a continuous outcome like price. Here, we are not simply classifying data into labels but are actually predicting the values of the price. The regression analysis has many applications in trend analysis, marketing, financial forecasting, time series prediction, biomedical and drug response, and environmental analysis. Let us look at some of the data mining applications. Sales and marketing. Now, by observing customer demographics and user behavior, companies use data mining techniques to optimize the marketing campaigns, improve segmentation, cross-sell offers, design customer loyalty programs, thus yielding higher ROI on their marketing efforts. In case of healthcare, data mining helps healthcare insurers detect fraud, predict patient outcomes, manage healthcare systems or customer relationship management, identify high-risk patients, and much more. In case of retail, most of the supermarkets face questions like how to increase profits, what will be the demand and supply in the next month, what will be the impact of seasonality on profits, or how should a particular product be priced, how likely a customer who purchased a laptop will purchase accessories as well, and many more. Right? So, data mining plays an important role in getting answers to such questions. Through more accurate data models, retail companies offer targeted campaigns to find the offer that makes the biggest impact on the customer. Fraud detection. So, coupling data mining with security to observe data anomalies, say in spending patterns, it plays a key role in identifying fraudulent transactions. It also helps identify bank loan defaulters and much more in banking and financial institutions. Well, that was all about data mining, and I'm sure by now you must have got a broad idea of what is covered under data mining and how it is done. Let us know your questions in the comments and we will take them up in the next episode. Stay tuned for more interesting videos in this learning series. Thanks for joining us and good luck.